click a lamp in one browser, it turns on in all the browsers. And this is either, I'm doing this just locally now, but this works across the internet. And this is going to show you the basics of a multiplayer game and how the game state is synchronized between multiple games. And I'm going to focus on the lamp blinking case because it's not really the easiest one to explain, but it's the one that has the most obvious effect on both sides of it, or for all the players involved. Okay, so we're just going to jump right into this. If you have any questions, just feel free to ask. And I'll give a quick overview. This is for a game called Edaqa's Room. It's a point-and-click sort of online escape puzzle game. There's a trailer over at my place here, and I don't know why Amazon's loading it slowly lately. This is kind of annoying.
Do you like puzzles? Do you want to escape? Would you trust Wendy with your life?
She's the main character, but she's only there at the beginning.
Assemble your team and come to Edaqa's Room. Play Prototype, a collaborative online escape game. Open now, but only the way in.
So that's what it's a collaborative game. And so I'm looking at the collaborative aspect today. In this show notes, you'll see a link to the game that gives you a discount if you've got from the stream. So use that if you want. It's been doing very well. People really like the game, and I just want to show a little bit about more how it works. So edaqasroom.com, follow the link in the show notes, and you'll get a discount on the game. And so again, I'm going to focus on this case here of how does the clicking of this lamp make this lamp here turn on and off. So let's go to the very beginning of this. What is this lamp? So the first thing we have is that I'm going to go over to Inkscape. So all my assets, all my scene assets are done in Inkscape. And mainly this is their SVG files. That's the biggest thing. I could do it in other things, but Inkscape allows me to edit SVG directly, which is really super helpful for what I'm doing. Otherwise, I'd have to find a whole bunch of different techniques to import and export files and convert them. I convert them anyways, but anyways. So with living room right, you'll see living room right. You should be able to see this on the screen. Inkscape extended bigger, but that's okay. I can extend this down a bit. Here we go. So we have this. You notice there's no background here. The backgrounds are added in a separate layer. And so this is just the main foreground one. So the first thing in making something click for all the players is making it clickable at all. You'll notice that the lamp is here. If I click on it, and you look over to the right side, it has an ID of lamp. This is actually the XML ID value. It has a lamp. But if you notice in the game, it clicks on and off. And the light goes on and off. So in this file, in this group, I think it's in the group. I'm going to find out. There's a whole bunch of items in here. And one of them, I'm hoping, is the light. This is one thing. It's hard in Inkscape to figure out where the things are. So this light might actually be on top of it. Ah, there it is. So the light's actually on top of the lamp. So here's the lamp and here's the light. And you can see that if I just move it around, you can move the light and that'd be somewhere else, but I'm going to undo that. So you have the light, and it also has the ID lamplight. It has this class called inert as well. And that mainly means it's a CSS class that when you click on the light itself, it doesn't actually get any messages. So it just goes through the lamp underneath it, which is what we want. Okay, so we have those two objects, the lamp and the lamp light. Now we have to go a little bit into the code of the game, and this is custom code for the, I'll just make this a bit smaller so you can see it. I'll just make it so you can see all this code. And so this code, the game is written in a custom engine. And the custom engine is something that I wrote for the web because I had a bunch of specific requirements that I think I've upheld, I met them. And these have the same name, so living room right. And you'll see living room right, it uses the foreground living room right.svg, and this is the one we're editing in Inkscape. And background, back living room right JPEG, and that's the actual background. Not just a carpet, this is the carpet and the wall, as you see in here. And it has a bunch of objects. So what we're looking for is going to jump right down to the object for the lamp. Now the lamp is a bit more complicated, is a bit more of a complicated action because it has a dual behavior. By dual behavior, it means it has two things. It can be on or off, and what happens in each of them, it does something differently. Even though it may seem like one cohesive switch type behavior. So by default, this is the case where it's its action. The default says we're going to pretend it's on, even though it's off here, but it doesn't matter. So the default action is you set the lamp on to false. Now, there's a variable in this engine called lamp on, and this is local to this scene, and when you set it to false, it's going to be false. And it gives the feedback message off. By feedback message, when you click this, notice that little message pops up, on and off. These feedback messages pop up on the screen itself as opposed to the ones up top, and there's nothing else that does that. Now we have a conditional action as well, and it's active when the lamp is not lamp on. So this is the on state, and this is the off state. In the off state, the feedback message is going to be on. In the on state, the feedback message is going to be off. It's reversed because logically when it's on, you're turning it off. And so if it's off and you turn it on, it gives this notice. Oh boy, time sure does fly when turning the lights on. And this notice is what comes up right there. Oh boy, time sure does fly when turning the light on. And that actually comes up for all the players. It's one of those ones that's universal. Notice goes to all players. So there it is. And you can see this one's Edaqa on Firefox. Firefox is just the name I put in the game for debugging. Obviously, you just see a normal player name. And then it sets the lamp on to true because you're turning it on. And then it does one additional thing, and we're going to get back to that later. This is part of the puzzle in the game, so it does one more thing because it's part of the puzzle. Now, what about that lamp light? When I turn it on and off, that lamp light goes on and off. And so we saw that in the Inkscape file, we have a lamp light object. And in my game, I have something called a visible flag. And a visible flag just says, when is this object visible? And in this case, it's basically when the lamp is on. If the lamp is on, this object is visible. And so this light toggling on and off is really nothing more than an object in the SVG file that's visible and invisible. But let's go down a little bit deeper. Obviously, this is just a file, and that's just an SVG. That's not what connects them together. This is what it's going to do. And I'm going to skip over the fact that I don't really load these SVG files directly into the game. These go through a pre-processing stage. And I'll get back to that in a future show about why they have to go through pre-processing. And it's kind of a real pain in the browser that you can't use SVG directly like this. You have to do some stuff with it first. Okay, so I have this. Now, skipping over a bunch of logic here, I'm going to go to the code that actually sets up those objects in the game. Something in the scene loader file. In the scene loader file, and I can just zoom in here a bit. I don't know why. Scene loader file, if you notice the name of it, I am doing TypeScript files. I'm just going to take a quick drink. Well, in this case, a TSX file, though I don't actually think there's any React in this code, but as things shift around, some things get the X extension, some things don't. So we have a bunch of things like prepared object. These are all the types involved, but let's just jump down to this prepare function, and let's just pretend this gets the loaded SVG and some other stuff, and jump down to the interesting bit right here. And these are the objects. What are my objects in this scene? And these correlate to this objects in this source file. In the game script file, these are the objects, and they have an ID and a description. So what we have is we're going to go through all the objects loaded for a scene, and we're going to mark them up somehow. We're going to say, what do we do with these objects? So the first thing we do is we get the element from the SVG file that we loaded, and you'll notice it's an ID prefix plus an ID, and this is the tricky part. I can get back to another show, is that let's just pretend this is the lamp here, and we're going to find an item called lamp. If I don't get an item I call it the lamp, it means the game has been compiled wrong, something broke, an asset is wrong, and it's actually going to hide the entire scene from the user, because I actually had a defect in one of the early ones that I had a small defect, a little tiny defect that wouldn't have been a problem. But because the error showed up, the entire scene showed up for the user, but without any of the dynamic code. And so basically they got the last key of the game because it wasn't hidden, it was just there. And they got a little bit upset then that, they missed half of the game. You can understand. So now if there's an error, it just shows the background and not the screen. And now we do something tricky here. And I'm going to save this for a later show as well. I don't actually directly use the SVG here as well. I did the pre-processing, and now I start creating dynamic groups in the SVG. It's a real pain. Just trust me on this. It's a real pain to use SVG in the browser. But I'll get back to this another time. Let's just pretend there's an animation route. Let's just pretend we're working on it directly. Now we go through and see what things can happen here. The first thing is say I have object visible. And that was this item here, this class here. For lamplight, we see it has visible. So this condition is going to apply this one, object visible. And all it does is changes the display to inline. And this is because there were several things in Inkscape that somehow changed the display. I don't know if this one has it. This one has some style and has a class, but this one doesn't have it. But a lot of times you end up with a display that isn't that. I used to remove the style, but now it was easier to just remove inline. All right, now I have a can activate function. And can activate checks a lot of things, like if the user can click on it. That is, if the user can click and do anything on it, does it activate? This one as well, where you click the note. The double sound is obviously because I have two versions of the game running right now and it echoes in both of them. So anything that you can interact with, this is things that have messages, actions, or anything, can activate is going to return true. So the first thing I do is I'm going to say, well, I'm going to set class clickable on this. These are actually CSS classes, or I guess they're just XML or HTML class. At this point it's confusing. But this actually maps to a CSS class where clickable actually sets up some things like it has the mouse cursor, it can be clicked, they're selecting, and it says what happens when it actually clicks. The first thing it does is it dispatches a UI event. It says, well, you clicked on this object and you should have feedback. And well, it calls the game object. This is like the game manager. It says, what am I supposed to do with this object? It activates the object, and we're going to skip over that part and go back into that. So when I dispatch this feedback, the main purpose of this feedback is you notice when I click, there's a little ring that comes around it. This happens on all items. Well, okay, some of them it doesn't. That was bad. But most items that you click on have this little ring that come up. Same with these books, even though I got something. Books go away, and I could show another one. There's every time you click on something, except special ones, there's usually that feedback message. Or there's something like this where it pops up. And so the feedback message is that little clicky, and on the lamp it's that circle, and that's supposed to be a visual feedback because you may not have audio on. So this is this here. This is taking care of this. It dispatches it somewhere in the UI. So this is one of the messages that we're going to get back to. This one is a UI message. I wonder if I should go back to it. And so there's a bunch of different UI messages depending on what activate object does. So activate object is the game code. And then the result type here says, well, what is my actual logical result? Ineffective does nothing. Edit value pops up text. And indicate says blink. So indicate is the one we're looking at. When I click this, you notice the lamp also blinks. It turns it on and off to make sure you know what you've been clicking. This is a generic one, and it can be modified, but I generally just leave it. Locked is a response that says, this is locked. You can't open it. And it makes the thing shake, and there's also a little lock that appears. And so there's two actions that are happening there. Okay, so that's sort of how that part happens. This dispatches a message. This is one message handled in the UI layer. This UI event feedback message will not propagate to the other servers, so the other people do not see that little flickering of it. And then the second feedback here, the one that blinks, is also just in the UI layer, and it activates on the object itself. But now let's take a look at this activate object function. This is in the game manager. Game manager, I believe. I'm going to go activate object. And I'm typing really slow because my hand's still a bit out of commission. So this scene object, what is this thing? Well, it's a high-level type for what we saw in the import file. This is a scene object. This is the scene object for lamp. Most of these files correlate directly to types in this scene object here. There is actually a compiler stage that converts that file and does some stuff on it, so not all its fields are the same, but it's close enough to follow what's happening. And you notice the first thing it does is check, do I have conditions? And that's the one we said here. Yes, it does have conditions because the lamp can be on or off, and it does different things when it's on or off. And so this evaluates through the conditions. It figures out which condition is active, and then it replaces the object with the active condition. So it does a merge operation on this. So what that means is it says whatever's outside of the conditions, find the active condition, and then merge all of this stuff on top of it. And then this becomes the new object. In this case, we're replacing both the action and the feedback message, so it gets completely replaced, but it doesn't have to. It can replace part of it or add to it very simply. So now that's the part that says, look, what is this active or is it not active? And it does something called evaluate var, and this goes through the state of the variable and says, what is the game state and what is that active condition? The active is not lamp on. And that evaluates that in the current game state to check, is it on or not? Then it does some other stuff with held items, but we don't have to worry about because we're not holding an item. The object is not locked, so it doesn't evaluate that. Does it have an action? Yes, it does. Now this is the interesting part. What does that action do? If it has an action, it's going to dispatch the action. And it's going to give the feedback messages back to that UI layer to say what happened with this. And that just returns that. And so you have, that's what this is doing. It's calling a dispatch action. It tells it the main feedback. And then text and notice. These are the things that show up. So the text and notice, if I go back there, there's a little bit of feedback text here. And there's a notice at the top of the screen. And they originate here. And what this does is this blocks the UI layer from having to know anything about the internals of the game. So the UI layer isn't evaluating these values itself. It's just taking something, this logic layer says, this is what you do. And it keeps the UI layer, the higher levels, dumber and dumber. And that's what I want. I want dumber and dumber layers so that it doesn't have to know too much. But now this dispatch action, so the UI layer called this function calls dispatch action. Now what does dispatch action do? Dispatch action. This is where the really interesting part starts happening. This is where we get lower in the protocols and we're farther and farther away from the UI. This part of the code can actually be tested and simulated without any UI whatsoever. These actions do not require UI. I haven't actually done that level of testing yet for automation, but it's separated this way so this could actually happen. This is array. This has a purpose. You notice this action is one item, and this action is an array of items. That is all that step is doing. An action can be one or more items. And the array here is really just iterates through and just takes the return to the last one. And you notice a big to-do here, what happens if there's locked and something should fail. And I've cleverly designed my games yet so that I don't actually have to solve that to-do because that's a real bitch of one to solve, so I just haven't done it yet, but I'm going to in a future game. And that one basically says, well, in a multiplayer, if two people do things that can conflict, one of them has to fail. And I've avoided that a little bit yet. But then there's this ordering one, and you don't see this one in the file, but let's just skip over that for a second. This is the one that synchronizes things, so that if you have set lamp on true, if you had a multiplayer game and two people clicked on the lamp at the same time, one person clicked twice really fast to turn it on and off. Well, then if you have a network delay there, it's not clear which state the lamp would end up in. What if one person gets the true message? If my true message gets through to the person before their false gets through after my true, you could actually end up with a mismatched state. So one person has the lamp on and the other person has the lamp off. So this is what this ordering comes in. And this order is added automatically by the compiler. And it checks this and it says, well, this is a, It checks this variable and it checks the naming and says, well, this is a global variable. It's local to the scene, but it's still global in the sense that all users share it. And what it does is it says, look, if you're sharing this variable, you have to need a proper ordering on all actions of this variable. And proper ordering means you do not respond to the action until it's gone to the server and come back. So the two people perform actions at the same time, there's going to be a total ordering to that because the server naturally orders it. It introduces a tiny delay, but that's better than having clients that get mismatched. And that's what this order part does. It simply looks at the order and it dispatches it with the ordering aspect to it. And so this dispatch just sets up a function that says whether it's ordered or not, dispatch it that way. Then we go through and say, what is our action? Well, we're using set. Set action in both of them. Set, set. Very simple. These are low-level sort of things in the end. So we just go through here. We find the set. These are not alphabetical in any way. You'll notice several other ones resolve the set, but that's not of interest now. So here's the set action. And we can skip over this call part because we don't have a call part. Call is an advanced function where a game can have special JavaScript code that's called rather than a simple variable, and it'll evaluate that instead. So all it does when we have set, it calls type set. And what variable? And this is literally array of variables. Set, the variable is lamp on. And what is the value? That is this one, true. Very straightforward. We're going to set a value to the action. And that's what it says. If this one's, we're going to set it to true, and that turns it on. Now when it's on, it takes the condition where it says it's on and sets it to false, and that turns it off, and that turns the light off. So we're just going two sets. I used to have a toggle function in the code, but that created a conflict in multiplayer. So actually I reduced it back to just set, and it's set on and set off. So this dispatch, it sets this message off and it sends it off to the server, and it goes through a layer. And I'm only going to briefly show this layer because this is where the game gets really interesting. So there's a game connector. Well, okay, no, that's just the interface to it. I have the game bus. There's a game bus, and the bus is where all the game messages go through. And this dispatches messages both locally and remotely. This is the one that handles the WebSocket connection. It takes the one in connect, in game, and joined, and it handles all the messages going back between the servers, back and forth. Where are they going to? What's happening with them? And so when I dispatch it, it ends up going through one of these messages. And the dispatch here, somewhere it ends up at send message. There's one little interleave between it, and it sends the message, and it makes sure it has a client ID, and it sends it. And then this one also receives the messages. So this is the low-level layer protocol. These just go to the server and come back. And the server has a really simple command to process these, and we can quickly look at that. That is in Python code then. Python server. Python has a lot of server code. And where do we have that? We have a dispatch message here somewhere. Proc game message. Game message. Okay, I forgot the name of the function. Send. Come on, what was the function? It's a very important function. I keep forgetting the name of it. Render game page. Game over. Sorry, it's in here somewhere. I keep forgetting the name of it because I haven't looked at it in so long because it just basically works that I don't use it very often. And I should remove those tokens and put them in a different file. Now I gotta go change some of them. Those are just the test tokens for PayPal. Come on, where is this stupid function? Maybe I put them all at the bottom. Maybe I was smart enough to move them. I don't know anymore. Publish game event. All right, this is the one I want. So it hits an endpoint and ends up publishing a game event. All this does is it calls, this is a Redis queue. It says next message key for this game client, gets the next ID, sticks to the message, and sends it out to the WebSocket room. And so all clients receive that message then. And so that's quite straightforward. That's how you send a message to the server and it comes back. And this is how the ordering is guaranteed. For those ordering ones, what happens is that because this is a single message queue, it sends messages out in order. Every client is guaranteed to get those messages in the same order. And this requires it to be single threaded on the server. So when I have to scale, the multiple clients or the multiple servers are going to have to scale per game room. One game room can't exist on multiple servers, but that's really not an issue. And it uses so little server load that I can't imagine me getting to a point where I need to scale anytime soon. I would really have to be like hundreds of simultaneous teams. Even then, I'm not sure I would overload the server. All right, so let's get rid of that. We're moving on from that. So this game bus sends messages to back from the server, and then we end up back at something called game state. Now, game state can also be tested outside of the server. Game state is the one that manages the entire memory of the game. And the memory of the game is basically all the variables. And this is the one, the eval var, we saw being used elsewhere to check if a variable was evaluated. And then this class game state maintains all of this state. And so an incoming message comes in, set. So this message set comes in. Remember the layer, because it was marked ordered, it sent it to the server first. It didn't respond locally. It sent it directly to the server and then it bounced back. And then really we just call set var. And set var is a very straightforward function. It's just basically a map of values and names. And it just sets it to this value. Simple enough. Done. Except, so this sets it in memory. So the game state now has this variable. But how does the UI actually respond to that? We know how both UIs end up being updated. So we know how these both clients, how they both have the correct state now because the message is sent to both of them. And it doesn't matter which one you click on, they both get updated. But how does the UI get updated from that? So you'll also notice here that initial feedback, this ring and these little feedback on off do not appear for the other client because those are local feedback messages. If you click here, they get them as well. But how does the UI update it? So I click here, the message is sent to the server, it comes back to both of these clients and they both update the state. But now how does that happen? This is actually it's very similar to React now. Now this is a React app, however, the vast majority of the game itself is not React. I am not using the subscription mechanism. It's backtracked. I backpedaled away from more and more of that. So the UI and stuff, all these UI, these are classic React controls for text and stuff. And even this inventory here, inventory display, this is all very standard React type things. But this game scene itself is not. It's diverged away from that, yet it works in a very similar fashion. And we can go back to the scene loader and see what happens there. Basically, in the scene loader, I have a function called update scene. And if you know React, just pretend that this function is like a component of some kind. And anytime the state changes, and this is considered a React state, this function gets called. So somewhere there's a hook function that says use game state. It grabs a state and it calls this function, and that is kind of what happens. It's a bit different now. And then this function goes, all right, the game state has changed. What do I have to do now? And it knows what scene it's on. So it's on this right living room scene, so it knows about all the objects. So what it does is it goes through a list of objects and says, oh, what are all my objects here? And it does the same thing. If there are conditions on the object, it evaluates them, because you can actually have different conditions for whether things are on or off. And this is actually relatively new and not used in the prototype game. It's used in the Carnival game, although honestly, I've forgotten where exactly it's used. So we can just skip over that one. The most interesting one here is visible. This is the one that applies to us. Because in the living room, right, we have this lamp light. Visible equals lamp on. So this little iteration loop here, this 4 objects, is going to go through all of these items: marble, toy, synthesizer, cactus, curtains left, curtains right, lamp, lamp. For optimization reasons, it may have skipped some of them because some of them can't react to state, so it may just remove them. But because there's only like 9 or 10 of them, it doesn't make a big difference in optimization. But this list is iterated through every time anything in the scene changes. Is this efficient? Who cares? It's 8 items, and you usually don't have that many on a screen, and JavaScript is really fast. And all of the actions this takes are optimized. If nothing's changed, then it doesn't tell the browser to change anything. So, object source visible. What does it do? It says, well, what is the current state now? And it calls evaluate var. This is from the game state object. Right at the top, we have an eval var function. And it takes a game state and an expression. This expression is from the source file. Whoop. I'm on the wrong screen. From the source file. The expression is this, .lamp on. A very, very simple one, which is simply a variable, a Boolean variable, and so that's going to evaluate that. What I'm looking for in the future is it's using a virtual engine right now, like a virtual machine, to evaluate these. And so it's a virtual machine written in JavaScript, which isn't fast, but again, there's so little code to evaluate, it doesn't matter. But in the future, I'm going to compile the dynamics directly into JavaScript, because that'll be an option. And then the browser will compile them directly. So as the games get more complex, I have a very clear path to how to make that very efficient. And so now I say visible. So I get the current state of visible, and this is the lamp. So the state changes, and it calls that code and evaluates, says, oh, the lamp is now false. It's not visible. And it checks, oh, previous visible does not equal visible, so let's do something. And I'll get back in a second. So I first thing to do is say, was it previously visible? Yes or no to what it is now. And yeah, there's a certain optimization here. Some things can have several little objects grouped together, it can contain things and stuff. So this case is a simple case. We have a single object that has a group of objects, and it's just basically going to say, all right, take this one object, and it's the group object, but basically it's the object on the screen, it's the lamp. Well, not the lamp, it's the light in this case, because it's the light that's visible or not. And it does one or two things. If it's visible, remove the hidden attribute. If it's visible, if it is visible, remove hidden. If it's not visible, add hidden. And this is just to the class list. And this is actually a CSS class where we can go into game CSS, and there should be something called hidden here. See, hidden, visibility is hidden. So this is basic CSS, and we're just adding or removing that right there. Now, you may be asking, well, why do I have to have this optimization here? Turns out, browsers are really bad at some of these optimizations. If I don't have this here, I could just go through this here and add or remove this classless item every time. This is apparently really inefficient for the browser. Even if the class list doesn't change, it kickstarts a process in the browser, which of course has to reevaluate all sorts of things in its rendering engine, which makes it really, really slow. And so what I do is I have this comparison here, because remember, this is evaluated anytime the state changes for any reason. Absolutely anybody in the game. So I'm here, and somebody's in another screen clicking stuff. They've changed where they are. They click these buttons. They click on this. They open the laptop. Something in the state is changing for all of these. And that means every time that changes, this code ends up being evaluated. So this is a lot of evaluations. So even though the browsers aren't like terribly slow at this, it adds up relatively fast. So that's why I check here. I say, look, if it's still the same visibility, we're not going to touch the DOM. And not touching the DOM is the main way to keep the browser fast. Only touch the DOM if something actually needs to change, because our browsers, they have a lot of issues. And this is something that's really hard to compete with in terms of like things like the Unity engine don't have this issue because they've been optimized for dynamic updates of their higher object trees, whereas browsers have not been. Even the modern browsers, even the faster Chrome, they're just not optimized to handle a lot of changes, so we minimize them. And so then there's a bunch of other things here you could do. There's more than just visible, but this object doesn't have any. This one, all we do is visible. We just toggle visible on and off, and that's how it responds to the visible. So now, as a sort of recap, we've gone through the whole process. When I click this here, this is because there's an object in Inkscape called a lamp. That lamp is attached in a file to a bunch of actions. I either set the lamp on or off depending on which state it's currently in. When I do that, when I click it, because this is an ordered action, because it has to be synchronized between clients, it sends a message to the server. That message is sent back to all the clients to make sure there's a total ordering. So if two clients click at the same time, we both end up in the exact same state. The client comes back. It gets a set message. It updates the state. And then in a React-like fashion, we end up in this function that updates, and every time the state changes, it goes through all the objects of the scene. It evaluates their current visibility, and if the visibility changes, it adds or removes it from the class list. Now that's a very sort of general overflow. I didn't go through all. This is a lot of code. I ignore some of the feedback at the high level, but that's fine. It just sends another message. So there's another message for turning these little circles on the screen. That's on the client side. It clicks and just sends a high-level message in the UI queue that does not go through the server. And that's basically it. That's how, when I click, go over here, a lamp in one client, it turns on and off in all of the clients. And for a bit more fun, there's a little bit of extra line of code. I'll show you that again in the code. It adds something to a variable called clock hour. What could that be? Well, the message says, oh boy, time sure does fly when turning on. Very few people get this clue. And if we go back here in the other room, you notice there's a clock there. So these synchronized variables apply more to just one thing. When I turn the clock lamp off, when I turn it on, the clock hand goes forward one. Every time I turn it on, the clock hand goes forward one. And this is the other clients. So this is across all clients. And this is how, if you have a team, you're supposed to notice this one person's clicking it, and somebody else might say, why is the clock moving? And there's a clue for that. And so that's the same part of the mechanism. And that's that multi-action thing about the text, is I don't only set the lamp on. When you're turning it on, I also increment the clock hour and divide by 12. It rotates it around there. And then the same way the lamp turns on and off, there's an additional one here about rotation, about the rotation of elements, of how things are rotated. A lot of commented out code because there are some browser issues. And that affects the hourglass here. When the state of the hour changes, it changes the rotation of the hour hand. Okay, so that's the general overview. I wanted to keep that short and focused on that flow, and if you enjoy this, let me know, and I can take any other behavior in the thing and go through similar things, say how they work, or go into more detail. The particular one is how I load the SVG is interesting, how the events come through, but this shared event system happens in all of them. I pick up an object, the same thing. Event goes to the server, comes back, and all people pick it up. There's local state too. Each user's in their own state. Various things change in each of them. And yeah, that's basically it. If you have any questions, let me know in one of the comments. You can also find me on Twitter and just post a question there and see my other videos. If you're interested, do follow me. If you're interested in the game, look at the show notes. I have a link to the game. There's a special for it. It is a team game, so it's better to play with 2 to 4 players. You can play it alone. It's just not as much fun. It can be, but certainly solvable with 1 player. Check it out, game, and let me know what you think, and let me know any questions about the technology of the game, puzzle design, or whatever you want. Thank you very much for watching, and I'll see you next time.